I'm Chloe Leslie.
Hi, I'm Malia Parsons.
And today we're presenting our food science investigation project. Our research question is, how does the increase of salt concentration affect the freezing temperature of ice cream?
So come on to the kitchen with us.
We observed that ice cream freezes faster when salt is added to ice. This leads to our research question: how does increasing salt concentration in an ice bath affect the freezing outcome of the ice cream mixture within 30 minutes?
These are the ingredients we will be using to make our
Here is some background information before we start the experiment. This graph shows freezing point depression. The solution freezes at a lower temperature than pure water, and the difference between those temperatures is called the freezing point depression. Water normally freezes at 0 degrees Celsius because hydrogen bonds hold the molecules together in a solid structure. When salt is added, it breaks into ions that disrupts those hydrogen bonds, making it harder for water to form ice. This lowers the freezing point. Because of this, the ice-salt mixture can get colder than 0 degrees Celsius. As the ice melts, it absorbs heat from the ice cream mixture, allowing it to freeze. The freezing point depression equation shows that the more salt we add, the greater the freezing point depression, which makes the mixture even colder, allowing it to become ice cream.
If the salt concentration in the ice surrounding the ice cream machine has increased, then the ice cream will freeze faster and reaching a lower temperature.
First, we assembled the rival 4-quart ice cream machine. Next, we prepared one ice cream mixture using heavy cream, whole milk, sugar, vanilla, and salt. We measured equal volumes for each trial. Then, we measured 20 cups of ice for each machine as required by the rival 4-quart system. We measured 5 cups of rock salt for our experimental group, then alternated layers of ice and salt until all materials were added. For our control group, we repeated the same setup with 20 cups of ice but no rock salt. Both machines churned for exactly 30 minutes. The independent variable was the salt concentration. The dependent variable was the final texture after 30 minutes. In the control group, the ice remained mostly solid. In the experimental, the ice and salt mixture began to melt. Before we wrap up this experiment, let me explain our data. Our results showed that the higher salt concentration in the ice bath reached lower temperatures and froze the ice cream more efficiently. With no salt, the ice bath stayed around 34 degrees Fahrenheit, and the mixture remained 70 degrees Fahrenheit, so no ice cream formed. Adding 5 cups of salt lowered the ice bath to 20 degrees Fahrenheit, allowing the ice cream to drop to 22 degrees Fahrenheit and achieving a soft serve texture within 30 minutes. As salt concentration increased, the freezing point of water decreased, creating a colder environment that froze the ice cream faster. These results support our hypothesis and demonstrate freezing point depression in a real-world food science application. This investigation shows how chemistry directly impacts food production and texture.